Okay, so we're going to take a look at 2019 and paper 1. We're going to take a look at question 2 now. Okay, so the complex number, the complex number z1 is 2 plus I, where I squared is equal to -1. Okay, so that's everything we know, nothing weird there at all. Z1 is this guy here, 2 plus I. So Z1 is 2 plus I. And we see that Z1 is plotted down here for us. So we go out 2 and we go up 1, and there it's plotted on the Argand diagram. That's pretty nice. Okay, and then we have this fact here. Z2 is equal to 2 times Z1. So Z2 is going to equal 2 plus I, and we're going to multiply that by 2. That should be an I there, sorry. Okay, so that's going to equal 4 plus 2I. So I now know that Z2 is equal to 4 plus 2I. Find the value of Z2, so its value is 4 plus 2I, and plot and label it on the Argand diagram. So it's 4, we go out 4, 1, 2, 3, 4, and we have to go up 2, so it's there. We're going to call that guy there Z2. Z1 with a bar on top, this guy here, is the complex conjugate of Z1. So that's our understanding of conjugate, yeah. Put the little bar on top, we know all about that. Write down the value of Z1 with a bar on top. Okay, so write down the value of Z1 conjugate. So Z1 conjugate will be 2 and an I. And up here, the sign in front of the I was a plus. So down here, the sign in front of the I is going to be a negative. So we have it written out, and we now have to plot it. So it's going to be 2 minus 1I, so it's going to be down there. And we're going to call that Z1 with a bar on top. Okay, that's Z1 conjugate. Investigate if the modulus of Z2 is equal to the modulus of this thing here. Z1 plus Z1 bar. Z1 plus the conjugate of Z1. Okay, let's see what happens there. Okay, so I suppose I have to do something first of all. I have to add, let's find out the modulus of Z2 first of all. So it's the modulus of this guy up here. So it's 4 plus 2I. So it's this guy here. The coordinates of him are 4, 2. The coordinates of the origin are 0, 0. So I'm going to go label up my points. I'm going to call that guy there x1, y1, x2, y2. And I'm going to put it into the formula. So it's going to be 0 minus 4 squared plus 0 minus 2 squared. And it's the square root of all of that. And that's equal to Z2 modulus, the modulus of Z2, which is going to equal 16 plus 4 squared of 20. Okay, so that's this guy here dealt with. Now let's take a look at this thing over here. So we now want to check Z1 plus Z1 bar. So Z1 conjugate is 2 minus I. So that's Z1 conjugate. We have to add Z1 onto that. So into this bracket here, I'm going to put in 2 plus I. Okay, so that's going to equal 4 plus 0I, or just 4. So if I was to plot this complex number here, it would be located here. So the distance from there to the origin, well, we know the answer is going to be 4. So we can just say that Z1 plus Z1 conjugate must equal 4, because Z1 plus Z1 conjugate equals 4. So therefore its modulus will also equal 4. And is is the square root of 20, is that equal to 4? I don't think so. False. Okay, so it's not equal. So we've done our investigation and it turns out they're not equal. Okay, so that's question 2, 2019. So that gives you an example of what to expect in your Leaving Cert. Good morning. So I suppose to get started, I'd like to just thank StudyClix for offering the service to teachers to do this. It makes life easier for finding questions. I suppose that's really what I use StudyClix for. And I suppose because I am using it, I probably should give them some credit for it. Although this is SEC material as well. So, right. So let's take a look at some complex number questions that will be kind of exam standard for you for your Leaving Cert and also for Friday for the test. Okay. So the first question we're going to look at is the 2018 question. So let's take a look at that now. I should say that this comes up every year. So it's very unusual that we can actually say to a student that something will come up on your Leaving Cert, but this seems to come up every year, so it's highly likely that this will come up on your Leaving Cert as well next year. Okay, so first question is a straightforward plotting question. Plot Z1, Z2 and Z3. Z1 is up here, Z2 is over here, and Z3 is over here. So to plot those three things, so let's do that now. Z1 first of all. So Z1 is minus 2, so I go to minus 2, and then I have to go up 3. So Z1 is going to be up there. And I should label that, and I'm going to call it Z1. I'm now going to take a look at Z2, and Z2 is minus 3, minus 2i, so he's going to be down there. Let's put a dot down there, and call that Z2. And then Z3 is going to be Z1 minus Z2. So I need to do some calculations to get Z3. So Z3 is going to be equal to minus 2 plus 3i minus 3 minus 2i. And we need to be really careful with this minus here. So that's minus 2 plus 3i plus 3 plus 2i. And then that's 1 plus 5i. So that's what Z3 is equal to. So it's 1 plus 5i, which is over here. So that's Z3. Okay, so that's full marks for that part A. And then we're asked to investigate if Z3, sorry, not Z3, but the modulus of Z3. If the modulus of Z3 is equal to the modulus of Z1 added on to the modulus of Z2. So really that question is checking, can we work out our 3 modulus? So first of all, we have to work out this modulus here, that distance. So I'm going to label up my point. So Z3 is located at 1, 5, and I'm going to call him x2, y2, and I'm going to call 0, 0, I'm going to call that x1, y1. So I then put that into my formula, and Z3 modulus is equal to the square root of 1 minus 0 squared plus 5 minus 0 squared. If you're talking to your mates in other schools or in other classes, they might do that question a little bit differently than I do it. So just be aware of that. That's going to be the square root of 26, I think, is it? So let's leave it alone like that. Now, let's take a look at the modulus of Z1 next. That's going to be this distance here. So let's label up my point. Z1 is at minus 2, 3. So that's going to be x1, x2, y2. So we put that into the formula again, and we get the square root of minus 2 minus 0 squared plus 3 minus 0 squared. That's the square root of all of that. So that's going to equal the square root of 13. And then we have to work out the modulus of Z2. Oh, don't know what I did there. The modulus of Z2. So the modulus of Z2 looks like this thing here. Let's go for purple this time. I need to work out that distance. I could be really smart here, and I could spot that, well, that one is 3 out and 2 down, and this one is 2 out and 3 up. So they should be the same length. But let's do it. Let's prove that just to be safe. So it's the square root of, the coordinates of him, first of all, are -3, -2, and that's x2, y2. So it's going to be -3 -0 squared plus -2 -0 squared. So it's going to be the square root of 13. So we want to check is, do you know what, guys, I'm going to make this a little bit smaller. So it's very hard for me to write because I'm writing on a very shiny surface here, so my writing tends to be a bit bigger than it should be. So I'm going to try and make this a bit smaller. And I'll push this in here so I can now work away in that box. So I'm now looking at something like is the square root of 26, is that equal to the square root of 13 plus the square root of 13? You might be tempted to say yes, it is, but it's not. And we won't get into why it's not, but we'll bang it into our calculator and we will get the square root of 26 is equal to 5.099 or something. And the square root of 13 is equal to SD, it's 3.61, and that's 3.61. So immediately that's going to be 7.2 or something. So is this equal? False. So our conclusion, they do not equal. Okay. I also think my mother is looking at these videos, so she is going to be appalled at my handwriting. So yeah, you can. Yeah, so it's not only you guys who are going to struggle to read that; it's also my mother for my shame. Z4 is equal to Z1 over Z2, so that's equal to. I'm trying to nab these up here. Copy. I'll throw them in here and maybe paste. Okay, so there they are there. So you obviously can't do that, but I can. So -2 plus 3i all over -3 minus 2i. So we have to do dividing here. That's really messy. Sorry about this. I'm going to try and be a bit neater because this is really important. Cut. Okay. So the fraction we're going to have is going to be -2 plus 3i all over -3 minus 2i. Again, this is dividing, so I need to use my system. My system suggests that I need to get rid of the imaginary part on the bottom. How do I get rid of the imaginary part on the bottom? I multiply by the conjugate, so it's going to be -3 plus 2i. And because I multiplied the bottom by -3 plus 2i, I also have to multiply the top by -3 plus 2i. So that's now going to equal 6 minus 4i minus 9i plus 6i squared all over 9 plus 9 minus 6i minus 6i minus 4i squared. So that now is going to equal 6 minus 13i plus 6 times -1. So that now is going to be, oh, something weird happened here because my i's should cancel out. So I went with -2i by minus 3, and that should have given me a plus 6i. So that should be a plus 6i in there. Yes. So they're now going to cancel each other out. Sorry about that. So that's going to be 9 plus 9, and that's going to be a minus 4, and I turn this guy here into a minus 1. So that's now going to equal minus 13i 6 minus 6 all over 9 plus 4. So that's going to equal minus 13. I'm going to make it smaller again, do my trick again. So it's going to equal minus 13i all over 13, which is equal to minus I, or minus 1i if you want. And that's going to be our answer. Okay, so let's take a look at how they examined this. They gave us some complex numbers up here, and they asked us to plot. They asked us to add them and subtract them. They asked us to find the modulus, and they asked us to divide them. Okay, so that's really what your test on Friday is going to be, that same standard. So that's an entire question on the 2018 paper, 25 marks. That's 25 marks out of 600. So that's 25 divided by 600 equals multiplied by 100 equals SD. So that's 4%. So if you answer another 10 questions like that across, or another 9 questions like that across across the 2 papers, you'll have passed. But obviously in our class, we're not aiming to not just pass, we're aiming to do quite well at ordinary levels. So yeah, so that's a standard there, that a leaving cert question. So again, they just got you to do some adding and subtracting. They got you to find the modulus. They got you to find a division and a bit of plotting as well. So yeah, look, they're straightforward enough questions, and they come up every year, so it's well worth your while becoming good at them. Okay, right, 2017 question 2. What happened here then? The complex number z1 equals a plus bi. Oh, a bit of panic here, letters instead of numbers. Where I squared equals minus 1 is shown in the Argand diagram below. Write down the value of a and the value of b. Oh, how easy is that? The value of a, well, a is the real part, and the real part is we go over 3, so a must be 3, and b is the imaginary part, or b is the coefficient of the imaginary part, so he must go down minus 1. Handy marks there for nothing. Right, z2 equals minus 1 plus 2i. Plot z2. Oh, lads, look at this. Simple question. So it's minus 1 plus 2i. He's up there. And we should label him as being z2. And then, look at that. Full marks. And then what's going on down here? A dividing. Look at that. A dividing question. So where is he? He is... okay, so I'm going to try and grab this guy here. Okay, yeah. So it's going to be 3 minus I all over minus 1 plus 2i. So we're dividing complex numbers. Our system has to come into play. We need to get rid of the imaginary numbers on the bottom, which means we multiply by the conjugate of the bottom, which is minus 1 minus 2i. We multiply by the conjugate, so we have minus 1 minus 2i on the top also. Let's multiply these out. I won't fall into the same trap as I did before. So it's going to be minus 3 minus 6i plus I plus 2i squared all over 1 plus 2i minus 2i minus 4i squared. And then, well, That's pretty good. I can now go minus 3 minus 5i plus 2, and that I squared, that gets turned to a minus 1. That's all over 1. These two guys are going to cancel each other out. They'll kill each other off. Minus 4 times minus 1. So that's going to be minus 3 minus 5i minus 2 all over 1 plus 4. So coming back up here, we have minus 3. We don't, sorry. We have minus 5 minus 5i all over 5. And they want a definite real part and a definite imaginary part. So we're going to go minus 5 over 5 minus 5i all over 5. And we can simplify that down to be minus 1 minus I. So let's take a look at that question. There was a bit more to it. I don't want to get near this yet, okay? So for your test on Friday, it's only as far as that type of stuff, okay? So let's take a look at what we were asked to do. We were asked to do some... We weren't even asked to do some adding or subtracting. It was simply, can this person divide? And can this person plot? And can this person read a plot? So if you could do those 3 tasks, you would do really well in that question. There was a little bit more here. The solve for Z. Look, you can see what's going on there. There's a bit of multiplication, and there's a bit of multiplication there, and you have to do a bit of common sense. But yeah, look, we won't go near that yet, okay? So it's just straightforward questions I want to examine on Friday. So that's it. So there's one other question that I did for my 6th year, so I'll also put that up for you as well in the same video. So that's it, guys. So I'll see you again on Friday, and yeah, stay safe in the meantime.